Hello, everybody. Hope you're doing well. Okay, so I'm sure people are still going to filter in, but we've got a hell of a lot to get through today. Can you just give me a thumbs up that you can hear me clearly? You can see my screen. If there's any issues, let me know in the chat. Cool, perfect. Great. Okay, so okay, you know all this. We talked about it yesterday. After I go through each part, I'm going to ask you if you have any questions on that particular section, and please don't hesitate to just unmute yourself and let me know. Okay. I am going to go through a hell of a lot of information, and I've actually made the slides as detailed as possible, just so that you're not feeling as pressured to make a lot of notes. But still, sometimes I might emphasize something verbally that you should just write down. Okay, we're going to start with if there's any questions from yesterday's training and yesterday's exercises, if you got stuck at any point.
I have a question.
Sure.
So not about the task we got from you, but I was going through the tutorial slides again to see it again, and I saw something where they can put a variable, but with pluses and minuses. And I was a little bit confused. So they put like a variable in the transform can put variable, and then they had a variable, and then they added variables to one another.
Yes, so we didn't go through that in the training yesterday. That's part of the training today. It's actually probably one of the first things we're going to do.
Oh, okay, perfect.
Yeah. It shouldn't be a minus anyway.
Really?
Yeah, because in compute variable, the only two things you do is you add them together or you create an average out of the variables. So,
Okay, thank you.
sure. Okay, any other questions? No? Okay, let's jump into it. Okay, so today we are focusing on our inferential statistics, which is essentially week 4 onwards. Okay, and inferential stats refers to basically the analyses or the tests of significance that you do to be able to make a generalized statement about an entire population. Okay, it's like if I sampled 20 IPCOM students, I need to do a test of significance to be able to actually make a statement about all IPCOM students as a whole. Okay, we're going to focus quite a lot on output interpretation. Now, unfortunately, there are limits with how much I can help you with interpretation, in the sense that I can tell you where everything is and I can give you your screenshots and I can explain it. But the only way you're going to get better at it is just familiarity. Okay, so even if you have to like print outputs out and like stick them up on your walls or whatever, just make sure you're looking at outputs a lot, because your eye will immediately start knowing where to go. Okay, so a few of the general SPSS functions that appear in all of your exercises. Okay, so yesterday we did like the filtering data, the recode into different variables, that sort of thing. Okay, today we're going to create an average variable. Okay, so essentially, like, usually what this function serves is, say you've got 3 different questions in a survey that ask a slightly different aspect of the same thing, of the same phenomenon. And you want to create an average variable that basically puts all those 3 aspects together to get like an average score. That's the function that this serves. Okay. So let's exit this, if it's going to allow me to. There we go. What we're going to do, we're going to do YouTube views as our demo. Okay. So remember, whenever we're messing with a variable, creating a new variable, it's always in transform. Okay, so start in transform. Yesterday, we went into recode into different variables. Okay, today we're going into compute variable. Those are the only 2 that you would use when you're messing with a variable. So compute variable. And this is what should pop up. Oh, you can see that everything I've put in there. Okay, this is a different thing. Hold on. Okay, start again. You know what? I could have just reset it. Cool. So our target variable. So whatever variable you're averaging. So for the sake of ease, I think I'm just going to treat it like average engagement, like of YouTube videos. So I'm going to do views, likes, and comments. Okay, they're all measured as a ratio variable, so it'll work fine. So I'm going to do number of views, okay, added to number of likes, added to number of comments, okay. I mustn't forget to actually give my variable a name. So let's give this average engagement. Now, how do you create an average, like a mean, right? You add up the things that you're adding and then you divide by the number of things, number of scores. So you would divide, which is this slanted symbol, and because there are three variables that you're adding, you're going to divide it by 3. Now, please be careful here. This is such a common mistake that people ask me about. But if you don't put brackets around your sum like this, okay, what the calculator understands is that it has to do multiplication and division first. So what would happen is that the calculator would literally just divide comment total by 3, and then it would add views and likes to that, which is not what we want. So make sure you put that sum in brackets. And then you can click OK. Okay. And then okay, no output. All right, there we go. Go away, output. Average engagement will appear at the bottom. Okay, as always, you need to go and label this. So this is the average engagement for videos, and then in brackets, likes, views, and comments. Okay, give it a nice label. We don't need to give it a value label. And why is that the case? Because value labels are only when you have a nominal or an ordinal variable, right? And to be able to create an average, right, just because it has to be numerical, right? We can only do that with interval ratio variables. So your average engagement variable will be interval ratio as well. Okay. And that's it for creating an average variable. Does anyone have any questions about that?
No, but
No?
honestly,
Okay,
I
cool.
don't think that we needed to know this because, as Julia said before, we only
Yeah.
added up variables or subtracted. So we didn't do average.
Okay.
Or I might be wrong, I don't know, but I don't remember doing that.
Can you see the exercise? So week 4, question 4 does require you to create an average grade variable. So you do need to know it. I think the overall, the total variable that you're talking about, I think you just maybe did that a bit more recently, and that's why it's a bit fresher in your mind. But you definitely need to know both. Okay. So with creating an average variable, what did I want to tell you? Okay. So whenever you're doing this with the variable, you need to pay attention to how your original variables were measured. Okay, and that information is always available in like the variable label or in, yeah. So all your variables that you include in compute variable have to be measured the same way for it to work. Okay, so if it's on a scale from 10 to 100, then every single one of those variables needs to be measured on a scale from 10 to 100. If it's measured as a ratio variable, then it's all good because it's all ratio. So it's just precise numbers. But if it's nominal, ordinal, not possible. And if one of them is measured on a scale from 1 to 10, and then the other one is 10 to 100, it's not going to work. Okay. the kind of question they might have like after you've done an average variable is, after creating this variable, what is the lowest possible value this variable could take on, and what is the highest? Okay, so example, if you're, oh, I see a hand up. Yes, go for it.
Yeah, I wanted to ask you about those levels of measurement. So you say that they have to be the same, but you also showed an example of the question, and they usually say of which variables should the new one variable can be together. So they say you the variables that you should use for creating a new variable. But what if they are on the different levels of measurement, or they would not create such a situation?
You simply can't do that. I want you to think about an average, how it works, right? Think about your GPA, okay? Would it make sense if one of your grades, one of your courses, wasn't measured on the usual scale, right, from 0 to 10, but was measured on a scale from 0 to 50? If you just included that course in with the other GPA, like 0 to 10, don't you see how that would completely inflate your GPA, and then you would not get an average that makes sense on a scale from 0 to 10? Does that make sense?
Yeah.
Yeah, like I say, like for statistics is measured from 0 to 50 because they're special. And you get a lovely 45 out of 50 for statistics. So your other courses are like, okay, 6.9, 7.8 plus 45. Create that mean, and you're going to get an average that is on an unknowable like scale. Will have no idea what that number even means because it's no longer on the scale from 0 to 10. Is that clear? Kind of, okay. We can come back to that. But yeah, basically, these variables, like what I just did with the demonstration where you're adding like views, likes, and comments, it's very unlikely that you're going to add 3 different variables that are so different because they're measuring something different. You'll only work with something like likes. I was just doing it for the sake of demonstration. But yeah, level of measurement has to be the same, but not just the level of measurement, exactly how it's measured. So 1 to 10 is not the same as 10 to 100. Okay. I'll show you in one of your exercises how they actually ask you to do this, but then they modified a variable so that the level of measurement is exactly the same. All right. Okay, lowest possible value versus highest possible value. So if you are working with a scale from 10 to 100, then the lowest possible value is 10. Okay, because when they say possible, they're not referring to what is the lowest score that a video got. It's not that, it's asking the possibility. So the lowest is 10. Now, when we create an average, right, what we're doing is variable 1 plus variable 2 divided by 2. So we would do 10 plus 10, which is 20, divided by 2 is 10. Okay, so even after the average, our lowest possible value is still 10, and our highest possible value is still 100. Okay, does that make sense?
So the highest and the lowest possible values don't change.
With an average, yeah, when you average out when you create an average variable, yeah.
Okay.
In fact, I actually think that I made a mistake on the next line, but I'll point it out because I copy pasted text, very naughty. But yeah, that's what I mean by this. Okay, then the other function is also using compute variable, but now you're not creating an average, just creating a total. Okay, and total can include variables that have varying, like can be measured in different ways, as long as you're aware of how they're measured in different ways. So one of the most common uses of like a total variable would be an IQ test, where they just kind of add up everything, and then you basically have like a range where if your IQ is between 120 and 140, then you fall into a certain category. Okay. Usually for this, they use the word overall or total when they give you the instruction. And as you can see in the screenshot, it's the same process. Go to compute variable. You give your target variable a name, and then you just add them up. Like you just put plus, 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 and you're done. No division. Okay, now in that situation, this is where I made the mistake here because I copy pasted. So ignore the first bullet point. I'll remove it from these slides. Basically, because it's a total and not an average, it doesn't have to be measured precisely the same way. Okay, so you can have one of the variables measured from 1 to 10 and the other one measured from 10 to 100 because it's just a total. When you're creating an average, it's because you're trying to get the variable back to the original scale. It's like with the GPA example, is that for all your courses, it needs to be on the same level because when you create the average, you still need to be able to understand that average from a scale of 0 to 10. With totals, you don't. It tends to work like the IQ test, where you just have a total. Okay, so again, your test question is, what would the lowest possible value be for this variable? Okay, a scale from 10 to 100, if that's what we're working with. If 10 was the lowest possible value, what we just did is we did 10 plus 10, given that they're measured on the same in the same way, which they usually are. Okay, 10 plus 10 equals 20. So 20 is now the new lowest possible value, and the new highest possible value would be 200. Okay. After they've asked you to do that, sometimes depending on the old variable, they would say, make sure to label the extreme values appropriately. So this is sometimes if you're working with ordinal categories. So value 1 is never, value 2 is sometimes, value 3 is often, and value 4 is always. And so what would happen is the new lowest possibility, which is value number 1, right? Because you got 1 plus 1, which is 2. Now 2 needs to be labeled as never. And 4 plus 4, which is 8, needs to be labeled as always. Those are the extreme values, the lowest and the highest. Okay. There is a question in your assignments that will ask you to work on that. Any questions about this? Make sure to ignore the first point. No? Okay, good. Okay, so it's just those two SPSS functions for now. Now the rest is going to be your tests of significance. And the biggest issue I've seen with students, like I said yesterday, is reading a question and having any clue what to actually do with it. So this is the way to break down the question. These are the things you need to look for. And I'm going to show you how you can also group some of the tests together because of similarities. But at the end of the day, this is a narrowing down process. So you need to look for specific information, and that will always help you narrow it down. Okay, and this is the procedure you need to follow for every single question. Okay, how many variables are involved in the analysis? And remember, this is excluding a variable they give you to filter the data. Second, what is the level of measurement of the variables? So if they ask you specifically what is the level of measurement, you obviously have to be specific. Is it nominal? Is it ordinal? Is it ratio? Is it interval? But for the sake of just breaking down a question, I want you to just divide it into categorical and continuous, because that's what makes the difference. And finally, what are the keywords that scream at you? Okay, so all your tests are going to have particular keywords. I have no idea why this is 1, 2, 1, but anyway. So as I go through all of the tests, we're going to look at these 3 things for example questions. Okay, so starting with what we looked at yesterday. So we're looking at a sleep study, sleep research. Sleep researchers are interested in the relationship between the number of hours teenagers sleep and their reported memory retention. They select 5 teenagers to investigate this relationship, calculate and interpret the results. Okay, so you start with how many variables? Okay, they're highlighted in that aquamarine color. Okay, so they look at the number of hours that teenagers sleep and their reported memory retention. Okay, your teenagers are your unit of analysis. Okay, what level of measurement are those on? Now in SPSS, you're often going to have to investigate this in your data set. You're going to have to look at the label, look at the value labels and be like, cool, is it categorical, continuous, what? As you can see from the information provided here, and this is more for your exam, by the way, but you can see that number of hours of sleep represent precise numbers, okay? Person number 1 said that they sleep 7.2 hours per night, okay? So that's ratio. Same thing for reported memory retention. If you look, it says number of facts remembered out of 20. So that's basically 0 to 20. So that's also ratio. So 2 variables, both of them are ratio. What keyword was used? So there's always a connection between variables. You need to find what word was used to connect those variables. In this case, it was about a relationship between them. Okay. There are 3 times in this course where they might use the word relationship. Okay, and it's specific. Pearson's R, crosstabs, and a chi-square test for independence. Okay, is this a test of significance? No, they haven't mentioned any of the words associated with the test. So no hypotheses, no statistically significant, no test of significance. It's just a descriptive stat. That means it's either Pearson's R or crosstabs. Okay, which one of those only deals with continuous or interval ratio variables? Pearson's R. Okay, so that's how you narrow it down. 2 variables, both ratio, a relationship between them, and it's a descriptive statistic, Pearson's R. Okay. Let's try it for the next one. Again, sleep researchers now want to know whether the teenager's biological sex has a relationship with the number of hours they sleep per night. They observe the following frequencies. Okay, so again, they're looking at number of hours slept per night, but is it measured in the same way? No. In the previous slide, it was measured as precise numbers, which means it was ratio. Here, based on the information you have, it's being measured as ordinal categories. So it's categorical. Okay, and biological sex, male, female, also categorical. It's nominal. So 2 variables, both of them nominal, ordinal. Keyword, it's a relationship between them. And again, it's a descriptive statistic. There's no words associated with the test of significance. Okay, so that is a crosstabs. Okay, so in a way, Pearson's R is the interval ratio option, and crosstabs is the nominal ordinal option for a relationship between 2 variables. Okay, is that clear so far? Yes, okay. You can see why I put such emphasis on the levels of measurement at the beginning. It's because it really is the deciding factor. All right. So here we go with the test of significance. Yeah, there are going to be 5 tests in SPSS. The 6th test that you won't do now is the one sample z-test. And the reason you don't do it in SPSS is because the z-test requires that you actually have population data, not just sample data. And in real research, which SPSS is designed for, you never have population data. You only ever have sample data. So it's only the one sample t-test. Okay, so you've got your one sample t-test, your 2 sample t-test, your one-way ANOVA, your chi-square goodness of fit, and your chi-square test for independence. Regression is not going to be tested in the SPSS test. It's because it was too soon. Okay, your one sample t-test. So you're testing a previously known population average against current sample data to see if the old one is no longer true. Okay, so if you read the question, previous research, they love to say that. Based on prior research or previous research, says the population average reading speed is 500 words per minute. We assume the population average reading speed to be less than 500 words per minute today. So do you see what they're doing? They're saying other researchers before me have studied this topic and they've got a population average for this variable, this one variable. I am doing my own study now and I get myself a sample mean. And I want to know if my sample mean is far away from the old or the previously known population mean. Because if it's far away enough, if it's different enough, then I'm going to be able to prove that the old population mean is no longer valid, no longer true. Okay. When we break it down into the three parts, okay, how many variables are involved? The only characteristic or attribute that they're describing here is reading speed. Okay. Level of measurement, 500 words per minute. Yes? Raise hand. Yeah?
Yes, is one sample t-test always used to test a previously known population average, blah blah blah?
Yes.
Or okay, so that's like the only use of it.
Yes.
Okay, thank you.
So all of these tests of significance that exist are not for funsies. They're not because researchers want to make their lives complicated. It's actually because you have all sorts of variables in the world, and there's all sorts of things that you'd want to test, right? Look at things from a different perspective. So this is the only purpose the one sample t-test serves. And because you have this previous research that's been done on your topic, like when you do your thesis in third year, before you even come up with like how you're going to go about your own study, you have to read all the research on your topic to establish what is my baseline, what is currently known about this topic. And that is always what appears in your H0. Okay, the point of H0 is like a baseline of knowledge. So if the old population mean is 500 words per minute, reading speed, whatever, then that's what's going to appear in your H0. So if you look at the H0 at the bottom, in this population, the population average reading speed is 500 words per minute. They will always give you that number. Okay. Now in H1, this is where you can hypothesize. So if they say, oh, we assume that the reading speed is not that, or if it's less than or more than that, that's where you put it in H1. Okay, why did I hypothesize that the average reading speed is less than 500 words? Because it was given to me as an instruction in the text. So that's something you need to look out for in the text. Does it use words like less than, more than, greater than, fewer than, whatever? Because that means it has to be a directional H1. All right, coming back. Okay, level of measurement. 500 words per minute. That sounds like a ratio variable because someone could read 0 words per minute, if they can't read. So yeah, ratio variable. And the key words. Okay, so they like to use things like based on prior research and previous research, but that's not the keywords that will scream at you. Okay, it's if you know that there's one variable and you know that that variable's interval ratio. Okay, the moment you start seeing any word associated with the test of significance, and that means significant, hypotheses, statistically significant, anything like that, then immediately it's a one sample t-test. The only other test of significance that uses one variable is the chi-square goodness of fit. And you can already rule that out when you have an interval ratio variable. Okay. Is this making sense so far?
So what are the main characteristics? How can we understand that it's a one sample t-test but not the chi-square?
It's got to do with the level of measurement. So because we haven't gone through the chi-squares, you'll see. But It's the level of measurement. So chi-square tests are exclusively reserved for nominal ordinal variables. They do not deal in interval ratio. So if you start with level 1, oh, we only have one variable, cool. There's two options if it's a test of significance, right? Then you go to the next, oh, what level of measurement? Oh, it's interval ratio. That immediately excludes the chi-square. And you have one option left, the one sample test. That makes sense?
Yeah, thank you.
Okay, cool. Okay, this is what your one sample t-test output will look like. Now, very important for your test, you need to be able to get an output only, nothing else, and be able to formulate hypotheses and conclude on them. Okay. So in your H0, you will have said something like the population average of this variable is a number. So in the previous example, it was 500. In the example I've got above, it's 52. Okay, whatever that number is that appears in your H0 is the number I've circled in green in the output, okay, your test value. Okay, that is basically the value that you are testing, the old population mean. Right. If you have a look at the output as a whole, all right, obviously it says one sample statistics, so it's pretty easy to see that this is a one sample test output. The first block that appears will always be your sample statistics or your descriptive statistics box. So you can see it tells you N, that's how many units were in your sample, and it's 55. What was the sample mean? It was 60.55. What was the sample standard deviation? Okay, so essentially what we're testing is my research studies mean is 60.55. Is that different enough from the old population mean of 52 to warrant saying that 52 is no longer valid? Okay, that's what we're doing. Right, so your test value, and this is a pretty straightforward one to interpret because you are just looking for a p-value, your sig value. Okay, and that's the sig value is always how you are able to conclude on hypotheses. So if you look at circled in yellow, you've got a one-sided p versus a two-sided p. Okay, which one's which? Okay, it has to do with, is your H1 directional or non-directional? Okay, directional is one-sided, non-directional is two-sided. Okay, and because we did have a directional H1, oh, that was for the previous oh no, this one's okay. Let's stick with this example on screen. If you read the last sentence, the research team have reason to believe that freedom of the press in Africa has improved and is now higher than 52. So it is a directional H1. So we would choose the one-sided P, and you can see that that's lower than alpha. And so you would reject the H0. Okay. So just to recap this, if they only provided you with this output and they said formulate the hypotheses, your I needs to go to the test value. That's your H0. Okay. Population average freedom of the press score is 52. H1, they said make it directional. Population average freedom of the press score in Africa is more than 52. And that's it. Any questions about this?
Do we need to say something about the T?
The T, you don't need to say anything unless they specifically ask you. I just circled it for now because sometimes they'll have a question saying, what is the value of the test statistic? And you just need to know that test statistic means the T value or the Z value or the F value or the chi-square value. In this case, obviously, it's the T. Yeah, but you don't need to report it if you're not asked because it doesn't allow you to conclude on anything in SPSS. Okay, another question?
Yeah, how could the conclusion look like based on this data and the question that is here?
Okay. So I wish I wrote down the H0 and H1 on the slide anyway. So if you remember, your H0 was population average freedom of the press score in Africa. So that was your variable, freedom of the press score in Africa. Yeah, population average is 52. So because your p-value is less than 0.001, remember to reject H0, it needs to be less than 0.05, less than alpha, right? If p is low, H0 has to go. So in this case, we would reject H0. So reject that the population average freedom of the press score is 52, and we would accept our H1, which is that the population average freedom of the press score is more or higher than 52. Do you see? We were given instruction to make it higher than 52. So reject H0, accept your H1. Does that make sense?
Yeah, thank you.
Cool. All right. That's a little demo of how to do your t-test. What did I use here? Video games. Okay. So, as usual, go to Analyze and go to Compare Means and Proportions. And you'll see here in this list, you've got 3 things you're going to look at. One sample t-test, independent samples t-test, and the one way ANOVA, because all of them compare means. So, one sample t-test. Okay, you've only got the one variable, so you can put it in there. Critic score. Okay, and then here you should see test value. All right, so this is going to be the old population average based on prior research that they will give to you in the question text. And I made it up. I think I put 78, whatever it is. So for this example that we just looked at on screen with the freedom of the press, if I was in that data set, I would have put 52. Okay, this is a different data file. And okay. Okay, so basically what I'm looking at here is I'm looking at the critic score given to video games, right? And the old population average was 78. And I just want to see if it's not 78 anymore, pretty much. You can see test value 78 over there, right? And my current average is 79.36. So already you can see that those are pretty close together, but you can't conclude on that yet. We're going to do a non-directional two-sided P, and again, it's lower than 0.05. So we would reject the H0 and accept our H1, that the average critic score for video games is not 78. Okay, does that make sense? Yeah. Okay.
I just have one short question. So in my conclusion, I would just report, like, I would just say in the population, like my H1, but I would not say what it is now.
So whenever you sorry, I had heard an echo. Not this one, sorry. Yeah, whenever you conclude, you just need to repeat the hypothesis that you're accepting or retaining. So in this example, if you reject the H0 because your P is low, then you just need to say, therefore we can reject H0 and accept the H1 that in this population, the population average reading speed is less than 500 words per minute. Okay, so you literally just repeat the wording of the hypothesis that you're keeping. Does that answer your question?
Yes, so there's no type of task that would me want to report my actual finding then.
Sorry, can you ask that again? It wasn't clear.
So they couldn't write a different kind of task for the one sample t-test where they want me to write my like my new mean, like report my findings. So it's always just repeating my hypotheses.
Yeah, so what they could do is mute yourself. Sorry, there's an echo. They can ask you, okay, what was your p-value? And you need to report the p-value. Or what is your t-value? And you need to report that. But for the purpose of the year one course, you actually are not required to report all of the statistics from output. You might just need to report your p-value just to prove like, hey, I know what I'm talking about. But there's no other way to conclude. You pretty much always are saying, do I reject or do I retain H0? That's the first thing, right? And if I'm rejecting H0, that means I'm accepting H1, and then you just have to write out your H1 again. And that's it. That's the only thing.
Okay, thank you.
Okay, moving on to the two-sample t-test, also called the independent samples t-test. Okay, so key thing here is instead of going through this procedure first, there's something that screams at you with the two-sample t-test if you read it in a question. It is a comparison between two groups, okay, and that's usually very easy to identify. And it is the only thing in this course that compares two categories. So if they tell you that they want to see if Dutch and German people differ significantly on something, what are they doing? They're comparing Dutch and German, two categories of the variable nationality. Okay, so that is a very clear sign that this is what you're doing. But for the sake of it, you've got two variables now involved in the t-test. Okay, because you're comparing two categories like Dutch and German, right? Your independent variable has to be categorical. So it has to be nominal or ordinal. Your dependent variable has to be interval or ratio. Okay. So if you read this question, sleep researchers divide the group of teenagers into pubescent and post-pubescent age groups. So you can see that they're measuring age, that's the variable, but they're measuring age as an ordinal variable, okay, in age categories. They are interested in whether these two groups differ significantly in their average number of hours slept per night. Okay, comparing them. So two-sample t-test. And I can guarantee you that number of hours slept per night is going to be an interval or a ratio variable, most likely ratio. Not just because it has to be that way, because I know it's a t-test already, but because it says average number of hours. You cannot create an average out of categories, so it has to be continuous. Their expectation is that pubescent teens need more sleep due to their developmental stage. Okay, that is an indication that they want you to make H1 directional. Right. If we look at the hypotheses, since you're comparing the two groups on their average hours of sleep, in this population, pubescent and post-pubescent teenagers sleep an equal number of hours on average. Okay, why is this the H0 that they're equal? If you want to prove that two different groups are significantly different from each other, right, you have to prove it. Okay, that's not your baseline, that's not your starting point. Okay, whatever you have to prove is always your H1. Your baseline is that they're equal, but there's no significant difference between them. Okay, so that is your H0. H1 in this case needs to be, in this population, pubescent teenagers sleep more hours on average than post-pubescent teenagers. Okay, you only make it directional like this if the instruction is given in the text. If they don't give any instruction regarding directionality, make it non-directional and move on. Okay, so we looked at variables, levels of measurement, and then the keywords are differ significantly or compare. Does this make sense? Yeah, cool. Okay, the t-test output is probably the most complicated. Yeah, sorry.
Can you come back to the previous slide, please?
Sure.
I have the question about independent and dependent variables here. I don't see, so here our independent variable would be age, right?
Mm-hmm.
That's why it's nominal and ordinal, and dependent therefore would be interval and ratio because it's hours of sleep. No? But isn't age is also interval ratio? No, because it has this 0 point.
Okay, so I did mention this yesterday. I specifically actually made a point of showing you how variables can be measured in different ways. Okay, so think about it as a survey question, right? What is your age? If they give you an open text box and you can put, I'm 29, I'm giving you my precise age. That's a ratio variable, okay, because it's measured as a precise number. If they say, what is your age? And they offer me options and they say 18 to 25, 25 to 35, then I put myself in the 25 to 35 option category, but they don't know my precise age. They just know my range. Okay. So even though they're both measuring age, one of them is ratio, the other one is ordinal. So you need to pay attention always to how the variable is measured. You can't just assume that it's always going to be ratio or something's always going to be nominal or whatever it is. Although nominal variables are pretty easy to see. Does that make sense? Does that answer your question?
Yeah, I have another one though.
Okay, sure.
It says here that independent two sample t-test used for testing a significant difference or comparison between two groups categories on a particular variable, but I'm not sure how can I apply this to this question because here we have like independent and dependent variables, so like I'm confused about this phrasing that we have two
Okay.
groups, we are testing them on something one, and I'm a bit confused.
Okay, sure. So I'm going to give you like a real world example, keep it really simple. Say we want to look at if there's a significant difference between Dutch students and international students on their GPA. So is the GPA between these two nationalities or two groups, is it significantly different? Do you see that we've described the students in two ways? We've given them a nationality and we've given them a GPA. Those two variables belong to the student. So those are your two variables. Okay. So the nationality variable, that's a nominal variable. We've said Dutch and international. Those are the two groups or the two categories that you're comparing. Yeah. The other variable, the GPA, that's the dependent variable. That's the particular variable that they're being compared on. Does that make sense?
Okay, so then here our independent variable would be the variable those two groups are tested on, right? Can we say it that way?
Um, the age group of the teenagers, that is our independent variable. Do
Yeah.
they fall into pubescent or do they fall into post-pubescent? Those are the two categories of the variable age group. And what are they being compared on? The number of hours they get per night. Does that make sense?
Yeah, kind of. I think I just have to.
A lot of students do get confused between the variable versus the categories of that variable. Okay, so I want you to always come back to the variable nationality. For some reason, that always clicks in people's minds, is that the fact that I'm South African, so being South African is not the variable itself. Nationality is the variable. Okay. South African is just the category that I put myself into so that that variable can be measured. Because when you don't know where someone's from, you don't say like, are you French? And if they say no, then you're like, oh, shit, that was my whole variable. No, you say, which country are you from? Or what is your nationality? That's the variable, and they respond with a category. Okay. I hope that helps a little, but we'll keep going regardless. Okay, so I'm going to show you two different outputs. I don't know how recently this was updated, but the new SPSS, I think it's version 31, has a different way of showing the t-test output, which is really weird. But anyway, this is the new one. I'm going to show you the old one first to see if you recognize the old one, and then we'll come back. Okay. this is the old version of the t-test output, where you get your usual sample statistics box. Okay, you can see in this output, good idea to be able to read output. Your variables will always be visible in output. All right. So if you have a look here, where can you see variables? Well, you can see Germany and Belgium, right, underneath country. That means that Germany and Belgium are the two groups that are being compared. And what are they being compared on? Right here in the row. How many hours they work per week. Okay. Once you've looked there, your eye needs to move right down to your Levene's test for equality of variances. I'm not going to go into the explanation of Levene's because that's theory and that's not too relevant for right now. The point is you need to interpret your significance value here for your Levene's test before you can interpret your p-value for your t-test. So essentially, two p-values that you have to interpret. And you interpret them the same way, by the way. You're asking, is p lower than 0.05? So if you look at the first one, it's 0.154. So that is higher than 0.05. So what that would usually mean is that we do not reject H0. We have to retain H0, okay? And what that means is that you're retaining the H0 of the Levene's test, not of the t-test. And that corresponds with equal variances assumed. Okay, because I'm not going through the theory and that explanation, I want you to remember this. If your p-value is high, meaning higher than 0.05, stick with the top row. Okay, so high, top. Follow the top row. If it is lower than 0.05, go to the bottom row. Okay, and since it's high, yes, question?
Yes, you just said that if the p is lower, blah blah blah, we reject the Levene's test hypothesis, not the t-test hypothesis.
Yeah.
What's the difference in here? Why are I have a lot of questions about that.
Yeah, so that is all theory related. So technically it's not really part of this training to go over theory because that'll be tested, in the exam. But for the sake of this, basically, when you do a two-sample t-test, there's a Levene's test embedded in it. And Levene's tests variance. Like, is the variance of group 1 equal to the variance of group 2? Whereas the t-test part, that doesn't test a variance, it tests means. Is the average, the population average of group 1 equal to the population average of group 2? Okay. So when you're interpreting Levene's, you're actually concluding on the implicit H0 and H1 of Levene's. And the H0 is that the two groups have equal variance. H1, so equal variance is assumed. H1 is non-directional, it's equal variance is not assumed, okay? Not equal variance between the two groups.
Yes,
Okay.
basically what I tried to ask is that in the conclusion for the two-sample t-test, we are interpreting the Levene's test output. We are not touching on the another p here, right?
We have two p-values to interpret. So basically this is a process where when you interpret a t-test, you go through the Levene's as part of your interpretation, but you don't actually write a conclusion for Levene's. It's just part of the interpretation process. So you come down to Levene's, you interpret the p-value. P is high, stick with the top row. Then you move to the right-hand side where you can see the t-test begins with the t-value here. And you move until you get to your p-value for the t, which is 0.179. And then you interpret again, is p lower than alpha? In this case, no, it's not. It's higher, which means we do not reject H0 of the t-test. We retain the H0. Okay. Does that make sense?
Not yet, but anyway.
What part is tripping you up? Because to interpret the Levene's, all you have to say is the sig value higher than alpha? Then stay high. Then follow that row until you get to the next p-value. and interpret, is it lower or higher than P? I mean, than alpha. And then you just reject or accept your H0. It's the same like logic, I think, as the others.
So I mean that like for the conclusion, we are using the final
Final P.
P, the second one.
Yes, exactly.
So Levine's P doesn't really matter.
It's not that it doesn't matter, it's that you don't have to conclude on it. You don't have to write out a conclusion for your Levine's p-value. But say, for example, you don't bother with Levine's at all, you just completely ignore it. Well, then when you look at your t-test, you've got two p-values. Which one do you choose? Do you choose 0.179 or 0.182? How do you know? Because both of them are insignificant, because they're both higher than p. But in the test, if they ask you, please report the p-value, if you reported 0.182 when the correct answer was 0.179, then you'll lose the mark. You'll lose the point. So that's what I mean when I say the Levine's test is part of your interpretation. It's like part of the process, even though it's not the final conclusion. Does that make more sense?
And when I write my conclusion, like what values do I write? Like which values do I write down? Because at the end I report a P, but for them to know that I did it right.
Yes,
Or,
you report the final p-value, the second
okay.
p-value.
Okay. And do I need to write down the other ones too, or it doesn't?
For the Levine's?
Yeah.
No. That's what I keep saying to you guys. You don't need to report the Levine's. You don't need to conclude on the Levine's. You conclude on the final p-value. But if you ignore Levine's completely, you're going to end up with the wrong p-value, potentially, right? So it's just part of the process. That's it. And I mean, they won't do it for SPSS, but for the exam, they could ask you write down the hypotheses of the Levine's test. They could just ask you that question. So if you are not clear on that theory now, then you need to go over it, or potentially if you want to join another training where I can explain it in more detail, because it's not really part of this SPSS training. Okay. Now the other output, this is the newer SPSS version, if you have that one. So as you can see, your group statistics are still there, and your final t-test is here. So you can see the t-values are there, and your p-values are there, but the Levine's test is missing, because it used to appear in the old one. So when you use a new version, you actually have to click something extra when you're running this test, and it's called homogeneity of variance test. And you can see it says Levine's test for equality of variances, and it only gives you equal variances assumed, which means it's only the top row, equal variances assumed. So your correct p-value would be in the top row. I find that way more confusing. I don't know why SPSS changed that, but just so that you don't get a fright, if that is the case. Okay.
I'm sorry, can I have one more question?
Sure.
So our H1 was non-directional before?
So I'm using all these different examples so that you get a feel for it.
Yeah.
But this one, you tell me, read the text again, and you tell me whether it's a directional or a non-directional H1.
I would say it's non-directional because there's no number in it, but it says like less or like no more. So because of that, maybe directional. Like, don't know.
So there's no number involved in the two sample t-test, in the sense that no number appears in the text and no number appears in your H0 or H1. So for the one sample t-test, we did have a number that had to appear there, right? For this one, we don't. For this one, we're just stating that the population average is equal for the two groups, right? So like you said, there is another indication in this text that maybe it's not non-directional, but what do you understand by directional, non-directional? Maybe let's start there. Because maybe that's not clear.
Yeah, I don't know, honestly.
Is it not clear? Okay. Okay, good. This is important. So I want you to think of like you're driving a car. Okay. You don't know, you're like heading off to like someone's wedding and you don't know how to get there. So you stop and you ask for directions. And the person you ask tells you, oh, it's way down there, but I'm not sure if it's on the left or it's on the right. Okay, so that's non-directional, meaning it's vague about whether it's left or right. Okay, which means when you head down that road, you need to consider that it could be left and it could be right. Yeah. So a non-directional H1 is vague like that. So in this example, pay attention to the hypotheses. So the first one is that these two groups of teenagers are equal in their average sleep. If it was non-directional, I would say that the two groups are not equal. Okay. I'd say pubescence and post-pubescence, they do have a different average of sleep. Have I said specifically which group sleeps less or sleeps more? No, just that they're not the same. Imagine with the nationality example. Oh yeah, there is a significant difference between Dutch GPA and international GPA. Yeah, very different. Cool. Which one has the higher one? Which one is lower? We don't know because it's non-directional. Okay. So if I deleted that last part of the text, we would keep it non-directional. But because that was added, their expectation is that pubescent teens need more sleep. They're saying, I think pubescents are going to be higher. It is directional. It's specific about which group is going to have the higher average. So you need to include that in your H1, that it's this group is going to have the higher average than the other group. Okay, does that make sense? Is that clear?
Yes, thank you.
Okay. The person giving you instructions says turn right, turn left at the end of the road. Okay.
And so when it's non-directional, I look at the two-sided P, right?
Exactly. So I want you to imagine that long road to the wedding and the left and right. Why is it two-sided? Because you have to contemplate that it could be both sides. Yeah. One-sided means they told you to turn right, which means you're completely ignoring the left. It's one-sided. Okay. Oh, student. Oh, they're late. Okay. How are we doing on time? Okay. Pretty good. Pretty okay. Okay, demo time. I used YouTube views. Okay, so analyze. Oh, go away, Zoom thing. 1 second, guys. The Zoom thing is blocking my analyze. Okay, analyze. Compare means and proportions, independent samples t-test. Okay, so you can see I've already put things in here. Your test variable will be, what are you comparing them on? Okay, so in this case, I'm looking at, I believe, lifestyle and information YouTube videos. I want to see if there's a difference between the number of likes that they get. Okay, so this will be your interval ratio variable up here. Then grouping variable will be your independent, right? And I've used theme, right? The theme of the YouTube video. Once you've added your grouping variable, you need to click on define groups. Okay. So in this variable theme, there were actually 3 value labels. There was 1 is lifestyle, 2 is entertainment, and 3 is information. I only want to compare lifestyle and information, which is 1 and 3. So this is why I put in the value labels. So be sure that you actually need to check what the value labels are of the groups you're comparing to put them in correctly here. And then you can click continue and then okay. And you'll get your output. Okay. Are we all good with that? With how to run it? Oh my gosh, I have too many data sets open.
I'm sorry, I don't think we did that in our tutorials. The grouping thing. I'm seeing that for the first time in my entire life. I was very careful.
Okay, so listen, if for this course they'd never required you to do anything other than group 1 and 2, then that's fine. But because they might still do that, and you always have to click on define groups to actually check. Hold on one sec. I want to do this again and show you what happens. Okay, I'm going to reset this. Cool. So I'm still going to put likes in here. And if I go theme and I put it in grouping, okay, do you see how I can't click on OK? And that's because I haven't, it's got question mark, question mark. So regardless, you do have to click on define groups to be able to move forward. And if your value labels are correct, they are group 1 and 2, and that is correct for whatever you're comparing, then great. Then you leave it as is and it's not a problem. And you click continue and then OK pops up and you're ready to go. Okay, so I'm just showing you on the off chance that they do want you to compare two groups that's not value 1 and value 2. Okay, it's a possibility. And then I just remembered, if you do have the version 31 of SPSS, if you're working with that in an SPSS test, this is where you need to click to produce the Levine's test. Okay. For some odd reason. And then you would click OK. Are we all good with that? Yeah. All right, guys, it's about that time for our break. So yeah, take 10 and I'll see you back here at 4:20. All right, guys, are we back? Let's get going. Oof, still 3 tests to cover. Let's go. All right, the one-way ANOVA. So I like to think of the one-way ANOVA as an extension of the two-sample t-test. So if the two-sample t-test was comparing two groups on a variable, so comparing Dutch and international on their GPA, a one-way ANOVA is just that now you want to compare more than two groups. Okay, so instead of dividing it into Dutch and international, maybe now you want to do the 3 most common nationalities in IPCOM, whatever they are, like Dutch, Vietnamese, and French. Okay, so now you have 3 groups, still all under nationality, 3 groups that you want to compare on their GPA. Okay, then you would do a one-way ANOVA. So when you're reading a question, as you start narrowing it down based on these 3 things on the right-hand side, it's going to look like it could be a t-test for a while. Okay, because you're going to ask how many variables are involved. Yeah, 2 variables. Cool. What's the level of measurement? Well, one of them is going to be categorical, and the other one is going to be interval ratio. Okay, so far, could be a 2-sample t-test, could be a one-way ANOVA. It is at the final stage that you need to actually count how many categories are being compared. So in some of your assignments, what they did was that they'd say, go run a frequency table for this variable to see how many categories are left. And then you run the frequency table and it shows you that, oh, there's 4 categories. And then it tells you, oh, we want to investigate if there's a significant difference between these categories. Okay, significant difference. So the same keywords as the 2-sample test, but because there's 4 categories, you would choose a one-way ANOVA over a t-test. Okay, so that's the only difference. All right, because it's the extension of the t-test, so your H0 is similar to the t-test. The t-test was that the population average of these 2 groups are equal. For the one-way ANOVA, it's that the population averages of all the groups are equal. Okay. Your H1 for the one-way ANOVA, however, is always non-directional. And the reason for this is that, say you have 4 categories you're comparing. To have a directional H1, you would have to say group 1's average is greater than group 2, but group 2 is less than group 3, but group 4 is greater than group 1. And you can already see it would be an absolute nightmare to have a hypothesis for all those combinations. So we keep it simple, we keep it non-directional, and we just say that the population average of the groups are not all equal. At least one of the group averages differs from the others. Okay. So I really want to look at the week 6 exercise question 4. So yesterday we practiced doing the recode into different variables with this question. So I want to quickly look at it together.
I'm sorry, how
Yeah.
do we understand the number of the groups again? The categories.
So either you need to go and investigate in your data set. So if I'm just struggling to exit my PowerPoint for some reason. One sec, I'm just going to stop sharing so I can leave this thing. Right. Okay. Let me reshare. Don't know why it does this to me. Okay, let's pick a data set. Let's keep it simple. VG sales, why not? So if they want you to compare all of the different genres of video games, and they want you to compare them on their global sales, right? It would be a bit hectic, but basically, if you want to know how many categories are involved, you could either look at the value labels, and you can see there's a hell of a lot of options. But often what they'll do is they'll say, like they'll first tell you to filter the data by selecting cases. So I think it appears in one of your assignments, and they ask you to do this. It's not week 5. Oh, it must be week 6. Yeah. Okay. All right. It's this question. It's question 2 in week 6. So this is YouTube views, which is great because that's video sales. We're going to do this quickly together. YouTube views. Lovely. So it says, before you start, make sure you select cases for the theme of information. Okay. So theme information is value number 3. So we go data, select cases. Okay, theme equals 3. And okay, cool. Now whatever analysis we run after this is only going to do it for informational videos. Okay, I want you to look at question A. Investigate the data set, for instance, by running some descriptive statistics. How many categories are left under the already selected theme information? So let's go do that. They say you can run some descriptives. You can also just run a frequency table for category. So you go analyze, descriptives, frequencies. You pop in category because that's the variable they've asked you to work with now. And you can just go okay, just for the frequency table. Okay. And if you look here at what it's produced, now you can see which category, how many categories there are that fall under informational videos. And it's 4: news and politics, education, science and tech, and nonprofits and activism. So there's 4 categories left. Cool. That's the only thing you needed to do to answer that. Okay. We're going to skip B for now.
Sorry, so what is like the breaking point for the ANOVA, like where we use the ANOVA, not the two-sample t-test for the categories, if it's more than what?
Okay, yes. So the two-sample t-test is only 2 categories. Like only 2. As soon as it's more than 2, it's in one-way ANOVA. It could be 3, it could be 10. But if it's more than 2, it's an ANOVA. Is that clear? Yeah, okay.
So it is less, the 3 basically is this number. Yeah?
Minimum 3, yeah.
For the ANOVA. So for the two-sample t-test, it's supposed to be just 2.
Just 2, yeah.
Okay, great. Thank you.
Cool. And then if you look at C, and I don't know if you notice this in your exercises, but when you do like question 4, and it's 4A, 4B, 4C, every mini question is building to the next one. Okay, so there's a reason they asked you to look at how many categories were left. So that in C, when they ask which inferential test of significance, do you need to use to determine if these categories differ on the number of views they get? So they're asking you, do these 4 categories differ on the number of views they get? Okay. That's typical ANOVA. Is that clear? Yes. Thumbs up. I can go on. Okay, I wanted to look at another question here as this example. So same week. So we did this yesterday. We're looking at the European Social Survey to explore the relationship between age and happiness for yada, yada, yada. Okay. Yesterday, we created age groups to work with instead of the variable age. Okay. So the original variable was ratio, and we wanted to create an ordinal variable, but still measuring age. Cool. Let's go to B. Okay, that's the level of measurement, ordinal, ratio, and yeah, this is probably interval ratio. It has to be. Okay, cool. C. If you want to know if people in different age categories differ significantly in their level of reported happiness, which test do you have to use? Well, you're looking at a difference between categories. There's only 2 options. It's the two-sample t-test or it's the ANOVA. How many categories did they ask you to create? 6. It's got to be the ANOVA. assuming we're doing okay on this so far, the ANOVA. Keep going. Okay, ANOVA interpretation. There are two parts to your ANOVA interpretation. So when you run the analysis, you put in your variables and whatnot, then you have to click on a post hoc test, which means the ANOVA tells you whether or not there is a significant difference between groups. That's number one. But it doesn't tell you specifically between which groups there is a significant difference. So if you have 4 categories, it's like, yeah, there's a difference there. There's a significant difference there. And you're like, cool, where? That's what the second part is for, the multiple comparisons table. Okay. So for the first part, okay, the table is labeled ANOVA, and you're looking for a p-value. Okay, and you can see this p-value here is less than 0.05. So that means you would reject your H0 and accept your H1, which I'll show you in the previous slide, if it'll let me. Right? So you're rejecting this H0 and you're accepting your H1, that the averages of the groups are not all equal. One of them, at least one of them, is different. Cool. Then you move down, you can ignore this middle table, and you move on to your post hoc test. Okay, the columns highlighted are the ones that you pay attention to. And because p-value is always the most important thing in your conclusions, your eye needs to go immediately to the sig column. All right. Now, if you look, there's a whole list of p-values, right? Every single significant p-value, meaning lower than alpha, means there's 2 groups that had a significant difference. So basically what this post hoc does, is it like runs a bunch of t-tests automatically comparing 2 groups at a time. Okay. So if we look at the very first p-value, it's 0.186. Okay, that's higher than 0.05. It's not significant. We can ignore it. Doesn't matter to us. We go to the next one. Okay, that's a significant p-value. If you move your mouse like to the left-hand side to see which groups were being compared, it was Africa was being compared to Latin America and North America, Caribbean. Okay, so those 2 are significantly different from each other. Okay, which one of them had the higher or the lower average? What is the dependent variable? It is laws and regulations that influence media content, whatever. Okay, to see that, now we pay attention to the green column. So follow, we're in this row, and our mean difference is 7.220. Doesn't matter what the number is, doesn't matter at all. It matters, is it a positive number or is it a negative number? Okay, if it's positive, like it is here, that means that the group that's on the left-hand side, the big one, it means that that's the group with the higher average. Okay, so it's positive, that means Africa has the higher average. Okay, significantly higher average. If it's negative, let's say for the one above it, negative 3.244, because that's negative, even though it's insignificant, whatever, it's negative, that means that Africa has a lower average when compared to Asia. All right, so that's how you interpret. You start with the p-value, have a look to see, okay, which 2 groups were being compared there. Then pay attention to, is it positive or negative in the mean difference? And then you conclude with a sentence saying, Africa has a significantly higher average than Latin America, North America, Caribbean. And always make sure to mention the variable, which in this case is laws and regulations, whatever your variable is. So if we were going to apply that to this example, oh no, this wasn't an example, sorry. Let's look at that question 6 again, just so that it's a little bit more consistent. This age group thing, right? Let's say that there was a significant difference between group 1 and group 2. Then you would conclude with people who are 25 and younger have a significantly higher average happiness compared to people between the age of 25 and 30. Okay, so that would be your sentence. And basically what you do is you just move down the list of p-values until you've interpreted every single significant p-value, but make sure that you don't include duplications. So just to give you an example, let's look at the top row. Africa was being compared with Asia in the top row, right? Then if you go down to the next block, Asia is being compared with Africa. So that's a duplicate. And you can see the p-value is the same, 0.186 and 0.186. So just make sure that you're not reporting duplicates. Okay. But every single p-value that is less than alpha, you need to report. Okay. Does anyone have any questions about this? No? Okay. Good. That's a good sign. Really good sign. Okay, let's do our ANOVA. What did I use? I must have used YouTube videos. Okay, so we got analyze, compare means and proportions, one-way ANOVA. Okay, your dependent variable, whatever it is, let's say number of views, it's always the interval ratio variable. And then your independent, let's go with theme, and you put that in factor. So IV and DV. Then before you go, just select post hoc on the right-hand side. And make sure you click on Shepe. That is the post hoc test. That'll produce your multiple comparisons table. And then you can click continue and OK. Okay. I think this didn't work because I probably have a filter on. I do have a filter on. Okay. This is why it's important to go and reset your filters all the time. Okay. Reset. Okay. I'm sure it'll work if I try it again. Okay, yep, there you go. Reset your filters, guys. And if we look at this output, let's make it nice and big. All right, so we start with the ANOVA table and we look at our p-value. Okay, so we would reject this H0. Okay, and what are we doing? We're comparing entertainment, lifestyle, and information videos, and we're comparing them on the number of views they get. Right. So if we're rejecting H0, that means we're accepting our H1 that says that there is a significant difference between at least two of these groups. Okay, there isn't a difference somewhere. So if we move down to our multiple comparisons, we look at our p-values. Okay, the very first one was significant, 0.004. So that was entertainment versus lifestyle. The mean difference you can see is positive, right? That means that entertainment gets significantly more views on average when compared to lifestyle videos. Okay. And it looks like, okay, you can see those two are duplicates, and those two are duplicates, and those two are duplicates, which means you only are going to report 0.004 and 0.028. Those are the only two significant results. Okay. And one layer of interpretation extra is, okay, so these two are both significant, which means when entertainment was compared with lifestyle and when it was compared with information, it was significantly different from both of them. And if you look at the mean difference, it's positive for both of them, which means that of these three categories or themes, entertainment had the highest average number of views overall. Okay, how are we feeling about this, interpreting ANOVA? Thumbs up. Okay,
Pretty good.
pretty good. Good. Good to hear. You know I'm going to drill you on your t-test in the practice time because it wasn't sounding good. If it makes you feel better though, the t-test is definitely what people struggle with overall. Mostly that and regression, which is not your problem today. Okay, now for the chi-squares. Finally, the chi-squares are actually a little bit more straightforward in SPSS. So I want you to think of the chi-squares as the nominal ordinal tests. Okay, they're called non-parametric tests. If you see an interval ratio variable involved, it's not a chi-square, guaranteed. Okay. The first one is the chi-square goodness of fit. Okay, great question, very easy to identify. It looks like nothing else. And what it's doing is testing if a certain distribution in the population is still true. Okay, what that means in simpler terms is, say a consensus was done. So not a consensus, a census was done that looked at how a country was distributed in terms of religion, right? So it wanted to know, is it like 40% Christian and 20% atheist and 15% Muslim, basically dividing the population into religious categories, okay? That is what a chi-square is looking at. If a previously known distribution is like whatever they found, and we do a new study that is challenging that old distribution, that's the goodness of fit. The question's super easy to see, like what it is, because this is what it looks like. Look at the third paragraph. Based on previous research, the researchers expected that 30% of the population of young people would have not attended a festival in the past 3 years, 60% will have attended 1 to 3, and only 10% would have attended more than 3. Okay, so whenever it's a population is divided into categories like that in percentages, it's a goodness of fit. Okay, as you can see, the variable that's involved here is how many summer music festivals young people have attended in the past 3 years. That's one variable, okay? And that one variable can have multiple categories. So if you look at the table, this particular variable has 3 categories, and the population is distributed amongst those 3. Okay, your H0 and H1, really easy as well. Your H0 is literally copy-paste what they gave you in the question. Okay, in this population, 30% have not attended a festival, yada, 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 give all the percentages. Okay. Because our chi-squares are only nominal ordinal, right? Directionality is not even a thing. So non-directional, just say that it is not true that 30% have not attended a festival, yada, yada, yada. Okay, super easy, copy paste from the question, very easy to identify. Okay, the output is even easier to interpret. This is what it looks like. It says chi-square test. It gives you a little frequency table in case you needed it. But again, your p-value is what you really look at. And it's lower than alpha, so you would reject the H0 and accept the H1, that it is not true that 30%, yada, yada, yada. Okay, everyone clear on this?
Yes.
Perfect. Right, so let's go. What did I use? Theme again. Okay, so I'm really enjoying the YouTube views data set today. Okay, for this one, we go analyze, and we go to where is it? Non-parametric tests, sorry. Non-parametric tests, legacy dialogues, and chi-square. It's not as intuitive as the others. All right, so you can see here, I'm just going to reset this. So whatever the variable is that they're using for the distribution, I'm going to just select theme. Okay. And then you need to put in the percentages that they've given you in the question. What you've got to make sure is that you're putting in the correct percentage value for the correct order that they show up in value labels. So let me just quickly go to the value labels. So for theme, we look at value. So if the order of it is entertainment, lifestyle, information, 1, 2, 3. If the question starts with 20% belongs in information, I need to know that 20 must go third, because information is third in terms of the value labels. Okay. So when you list the percentages, make sure they correspond to values 1, 2, 3, 4. Go back. Okay, to enter the percentages, you need to go down here to your expected values, click on values, and say it's 20% first, then you put 20 and you click add. Next is 30. I'm making these numbers up, by the way. Okay, and then the third one, because there's 3 categories there, would be 50 because it has to all add up to 100. Okay, add. And I believe that is it. You can click on OK. Then you get your very nice output, and this result is significant. Are we all good on that? I think so. Okay, your other chi-square. So if your first chi-square only had 1 variable, your second chi-square has 2 variables, also nominal ordinal. And yet again, the most important keyword here is relationship. Okay, so just a reminder that keyword relationship appears in 3 possible scenarios. Pearson's R, crosstabs, and the chi-square test for independence. The chi-square test for independence is based on a crosstab. They're friends. Okay, so that's why they're both about a relationship. But very key, because I want you to read this text again, and it's exactly the same question as I used for the crosstabs example. Right? They want to know whether the teenager's biological sex has a statistically significant relationship with the number of hours they sleep per night. Okay. If I left out statistically significant, I have no reason to believe this is not a crosstabs. It could just be a crosstabs. But because I added in statistically significant, okay, that's telling me, no, this is an inferential test. So it's not crosstabs. It has to be the chi-square test for independence. Okay.
So they're always going to include that those 3 words for chi-square test for independence?
It's not that they have to say statistically significant. It's that significant, that word, is associated with the tests of significance, right? So you need to keep an eye out for these kinds of things. Like if they ask you about a hypothesis, so they give you this and they leave out statistically significant. And this is question 1. And then 1.1, they say formulate the hypotheses. Well, the hypotheses are only for the tests of significance. So that is indicating it has to be a chi-square test for independence because it's not a descriptive statistic. Does that make sense?
Yeah, it does.
Okay, and because you're testing a relationship, that is what appears in your H0. So in this population, there is no relationship between teenagers' biological sex and the number of hours they sleep per night. Okay, why is the H0 that there's no relationship, right? Again, in this situation, what would you need to prove? What would you need proof to say? If there is a relationship between biological sex and how many hours people sleep, that's what you have to prove. So that appears in the H1. Your baseline is that there's no relationship. Okay. Also, non-directional chi-squares, keeping it simple. Okay, and output is also pretty straightforward. When you run the chi-square test for independence, a crosstabs will appear because it's based on a crosstabs. But unlike a crosstabs question, you can literally ignore it. You're not looking at the different percentages. That's not how you're concluding on this. You're looking for your p-value, which is down here under chi-square tests. Asymptotic significance, that's your p. And you want the one that says Pearson chi-square. It's 0.017, which is lower than 0.05. You would reject the H0 and accept the H1, but there is a relationship between the two variables. Are we good on this?
Yes.
Okay. Lovely. So I don't really need to demo this unless you want me to. Basically, you start out, when you do the chi-square test, you start out doing a crosstabs, essentially. So you go analyze, descriptive statistics, crosstabs. You enter your independent in the column and your dependent in the row, same as before. You click on your column percentages because that's always important. So cells, column percentages. What's most important here is that before you click OK, you click on statistics and you click on the chi-square because that's what's actually going to do the test for independence and not just a crosstabs. Then you can click continue and OK, and you'll produce your chi-square. Does anybody want me to do this demo? Or are you good?
Please.
Yeah? Okay. If I can leave. Sorry guys, I'm just stopping sharing so I can get out of the PowerPoint. Okay, let's look at pubic news. All right, so go analyze, descriptive statistics, and here you would find crosstabs. All right, I've already put the variables in. I just chose these at random. So this is race. Okay, so obviously that's categorical, that's nominal, basically all the different racial backgrounds. And then for your rows, that would be your dependent variable always. And this variable has to do with how often you come across a news story about fake news. I just selected them at random. But independent in column, dependent in row. Go to cells, and you'll need to, oh, I don't know why it's down there. You would need to select column, right? I already selected it. Select column, continue. And most importantly, statistics. And this will be unselected, so you need to select chi-square. And continue. And okay. And then there's a massive crosstabs and your chi-square test. Yeah, you good? All right, almost there, almost done. Okay, so one of the ways that I suggest that you try and remember all these different versions of testing variables is basically to group them by similarity, right? So the first one is there are tests that compare groups, okay, or they compare categories. And that's the two-sample t-test and the one-way ANOVA. So if you see the word compare, comparison, are these two groups different? It's going to be one of those two. For your chi-squares, so only if it's a test of significance and it's only nominal or ordinal variables involved, it has to be one of the chi-squares, no other option. And then the last one is if you're comparing an old population mean versus a new sample mean, right? It's going to be your one sample t-test. And I've added in the one sample z-test here, but it's not an SPSS, just for your exam. Okay. So this is all there is to it. The rest is going to have to, you're just going to have to remember the keywords. Like if there's two variables involved, what exactly is the connection between the variables? And you can go over the slides. Does anyone have any questions about all this now? No? Okay. I expect there will be questions as we do some practice, which is totally fine, welcomed. Okay. These are the questions I would like you to do, but because we had such a hard time with the two sample t-test, I want you to do that one first. Let me just double check which one it is. Okay, it is going to be week 5, question 3 is the one that I want you to start with. So this one. And then if you get stuck during the process, during interpretation, just let me know. Unmute yourself. Okay. I'm going to mute myself and turn off my camera, but I'm right here.
I have a question.
Go for it.
Um, so I just created the new variable by adding up the three variables together and name it just like overall responsibility. And I was wondering, do I have to add values now? Because I added a label, but I wasn't sure about the values.
So, good question. To know whether or not you need to do that, you always need to go back to the original variables to see if they had value labels. So let me share my screen completely. Okay. So I did it already. So I created the same variable. And if you look at the original variables, so these three, P5A, okay, they're all measured in the same way. And if you click on the values, you can see that they're measured as ordinal categories. Okay. So what happened when you added these three together is that for the first category, it was 1 + 1 + 1, which is 3, right? So when you label your new one, you're going to give it the value 3, and you're going to label it a great deal. And because they only want you to do the extreme values, you're going to do the same for 4, right? 4 + 4 + 4 is 12, and you would label that none at all. So it should look like this.
Okay. Okay. Makes sense. Thank you.
And just to add on to that, just remember that the value labels are only needed if we have a ordinal variable, categorical. If it's interval or ratio, it will always appear as none.
Could you tell us again when we are grouping the variables, like which group to put which?
I'm so sorry, can you repeat that?
So when we are grouping the variables in the two sample data, like which group do I put which variable to?
Okay. Let's have a look. Let's have a look. So you're talking about this question, right?
Yes.
Yeah. Okay. So you can see that what they're comparing is basically Democrats versus Republicans, right? Can you tell that from the text?
Yeah.
Yeah. Okay. So based on that alone, it's already a two sample t-test, yeah? And if they're comparing Democrats and Republicans, those are the categories. The overarching variable for that would be what party do they lean towards? Okay. Okay, so you know that. You know the independent variable now. What's the other variable that's involved? So if you read again, people who lean towards, on average, attribute greater responsibility to others. That's the other variable, right? How much responsibility do they attribute to others? And like I said before, you know how every question builds towards the next. So this variable that you created up here was about responsibility, attributing responsibility. So they want you to use this one. So those are your two variables. You've got party leaning as your independent, and the new variable that you created, which is whatever you named it, overall responsibility. Is that your question? Does that answer it?
Yeah, but when I run, or like when I'm putting in the variables, don't I need to like group them, like to choose like Democratic Party and what was Republican Party?
Okay.
Like,
So, all right, let's have a look at the data set. Let's go from here. That's not the correct one. It's too many open. All right, so what we're looking at is party leaning. There we go. If we look at the party leaning and we look at the values, so 1 is Republican, 2 is Democratic. Don't worry about this 9, other, don't know. It's usually like a bogus value. So 1 and 2, good. So when we run it, we'll go analyze, compare means and proportions, independent samples, t-test. Okay, I'm going to reset this. Okay, so your test variable is always the dependent variable, which in this case was the variable you created, overall responsibility. Hold on. There we go. And then your grouping variable would be literally the variable that was measured in groups, which is your party leaning, which is, okay. And you just need to click on define groups, and it's already 1 and 2, which aligns with the value labels. It was 1 and 2. So you click, oh, continue. Oh, and because I have the new version, I have to click this one as well for the Levines, and you click OK. Is there something that I did there that you didn't do before?
no. But before there was the one example that you showed. It was like based on percentiles or something, and then like about the grouping, or maybe I remember wrong. I don't know.
I'm not sure. Sorry, I'm not understanding your question. Has it got to do with this t-test? Does it have to do
With
with
this one, like when we are choosing our groups, like
Okay.
does it matter which category do I put at group 1 or group 2?
It needs to align with how it's been labeled in the data
Okay.
set. So
Yeah.
that's the only thing. So
Okay.
I showed you it was 1 and 2. And if you look at this, if you look at this variable and you look at the way it was labeled, indeed, it is 1 and 2, Republican and Democrat. So it's perfect as it is. No changes need to be made.
Okay, thank you.
How are you guys doing with interpreting the output if you've already done the question? Would you like me to go through it with you to see if you got it right? If you're not there yet, give me like a thumbs down if that's a possibility.
I'm not there yet, but I have another question.
Sure.
The hypotheses in D, I'm not quite sure about the wording right now. Like, do I say,
The wording.
yeah, like which one is different or which one is equal?
I hear you. Sometimes the wording of the text can be really confusing. So just remember, you don't have to use their phrasing. As long as you get your variables correct and you put it in the basic structure, you're good to go. Okay, so for your basic structure for H0 for a two sample t-test is population average of group 1 equals the population average of group 2. It's always equals 2. Okay, so you never include the directionality thing. It's always equals 2. So in this case, what we would say is that the population average responsibility attributed to others is equal for the Democrats and the Republicans. Okay. Another way to do it is, if you actually just want to write out the way they said it, you could say, literally, people who lean towards the Democratic Party on average attribute equal responsibility to others when it comes to preventing fake news from spreading compared to Republican-leaning individuals. So you can use all of their wording. Just make sure that for your H series, it's equal, not greater. For your H1, you just change equal to greater because it's a directional H1. Does that answer your question?
Yes, thank you.
I have the question about the C part. Which test of significance would be used here?
Yeah.
Because just like logically, since we have the question about the Levines in the E, we could say, just like logically, we could say that it's ANOVA, but like if I didn't have that, I'd have no idea how to answer this question, like because based on what?
Okay. You connected the Levines to the ANOVA, but the Levines test is not part of the ANOVA. That's the first thing. The Levines test actually should have given you the clue that this is a two sample t-test, but they won't always ask you about Levines. So I don't want you to focus on that. So do you remember what we talked about in terms of like the two sample t-test and the ANOVA are very similar in a couple of ways? What differentiates them? Do you remember what we talked about? Or do I can repeat it if you need me to. I just want to ask.
At this point, I don't get anything once again. So.
Okay, all right. So essentially, both of those tests are always about a comparison between categories or groups. Yeah. And so if you look at this text, it literally uses the word compare. That's a key word. So if you're comparing groups and which groups are being compared, or if you read the text, it says people who lean towards Democrats have a different opinion on something when compared to Republicans. So do you see Democratic, Republican? These are two categories that are being compared. So that should be what stands out for you. Now, deciding on whether it's a two sample t-test or it's an ANOVA, how many categories are being compared? Two. It's Democrats and Republicans. That means it's a two sample t-test. If they were comparing Democrats, Republicans, and independents, that's three categories, that would make it an ANOVA because that would be more than two. Did that clear that up?
So basically, it's because we are comparing two groups, right?
Yes.
In here.
Yes.
Okay. Okay. Thank you.
So, in the D, we formulated our H0 and H1 based on the tags. And in the E, like, what exactly do we need to do?
Okay, so they won't ask you a question like E in the SPSS test, just so you know. That's more for the exam. But for the sake of doing it now, I'm going to pull up. No, actually, I can't pull it up. Don't have it. Anyway, so the Levine's test is embedded in the two sample t-test, right? It's like a test within a test. And the H0 and the H1 of the Levine's test has the same basic structure as the hypotheses do for the t-test. So, but instead of looking at population average, right? Average is a mean. The Levine's test looks at variance. Okay, in week 2, you learn about variance. Okay, we also covered it briefly in the last training session. So your H0 for the Levine's test is that the population variance of the first group is equal to the population variance of the second group. Okay, your H1 is non-directional, and it's that the population variance of group 1 is not equal to the population variance of group 2. Okay, so those are the hypotheses for Levine's. Basically, instead of using population mean, you just say population variance. Otherwise, it looks exactly the same as your t-test hypotheses. Does that answer your question, or do you want me to explain a little bit more about variance and why it's involved? I can.
Could you just a little bit, please?
Just a little bit, okay. So variance is a measure of variability, right, from week 2. Variability tells us how much variety there is in a data set. Variety in the sense, is there diversity, or is everybody in the sample pretty similar, pretty homogeneous, right? So I want you to think of this example. Let's say I'm comparing Dutch and German people on how they form their political opinions, or whatever it is. What if German people are diverse? So that means that there are going to be a lot of Germans that are like Dutch people and a lot of Germans that are not like Dutch people. You know what I'm saying? So there's diversity within Germans. And what if there's also diversity within the Dutch population, meaning some Dutchies are like Germans and some are not? Diversity. That's got to do with variance. Okay, so if there's high variance in a population, that's high diversity. Do you see how the more diverse the populations become, the harder it is to say that they're significantly different from one another? Whereas if all Dutchies were alike and all Germans were alike, and we could prove that they were far away from each other in their mean of whatever, then we can say these two are significantly different. Okay. So do you see why variance plays a role in being able to say that these are two different groups? We have to include it in the math. Does that make sense?
Yes, thank you.
I have a question.
Tell me.
I think I did did something wrong because in F, the last part of the task 3, I ran the test and I reported the means, and then I focused on the Levine's test, and then I reported P and alpha, and I realized I have a smaller P than alpha. Oh no, I think it's okay, because then the variance are not equal, right? Then I just have to look at the other row.
Exactly.
Okay.
Exactly. So yeah. So because you guys are you seem very interested in the Levines, I want to give you a more complex explanation as to what's going on in the output. So wherever I put it, I'm guessing your guys' output looks a bit more like this one, not the newer version that I have, which is weird. But anyway. So if we look here and let's pay attention to the Levines section. Do you see here it says equal variances and then equal variances not assumed? Do you realize that this is the age 0 of Levine's? Variance of group 1 equals variance of group 2. And equal variance is not assumed is the H1, the non-directional H1, which means the two variances are not equal. So what happens when we interpret this p-value is we say, well, if p is low, H0 has to go, right? So if your p is low, you would reject the Levine's H0, which means you would reject the top row and you would accept the H1, which is the bottom row. Yeah? And then you would follow the bottom row towards your final p-value, which you would use to conclude. I just gave it to you in a much simpler way to remember to avoid all the theory. But basically, if p is low, go low. If p is high, go high. Does that make sense?
Okay, yeah, that makes sense.
Could you please do week 4's question 3?
Sorry, can you say that again? I don't know if your sound is a bit, I can't hear you very well.
Sorry, could you please do week 4's question 3?
Week 4, question 3, sure thing.
Mm.
Okay. Is there a specific one that you want me to do, like, or do you just want me to go through A, B, C, and D?
Yeah, just go through it just to make sure that I
Okay. So if you read the text, it's talking about basically a review system to assess movies. It's called the critic score by the tomato meter, which ranges from 0 to 100. Okay. So that should already tell you your level of measurement, that this is a ratio variable. Why? Because 0 is possible and it doesn't go below 0. So, okay, this tomato meter was the topic. One sample t-test, yes. So we've done level of measurement. How many cases are there in this data set? So whenever you need to see the sample size, the group size, how many cases, okay, all of that information is always available in your sample statistics, right? N is your symbol for sample size. So your answer should be 290 cases in this data set. Okay, write down your H0 that was tested in this analysis, assuming a non-directional H1. What is H1? Okay. So whenever you need to do a hypothesis, you always need to go to your basic structure for that test. Now, the basic structure for a one sample t-test is population average equals a number. Okay, that number either is going to appear in the text. In this case, they want you to see it in the output. Okay. So we start with, in the population of movies, the population average tomato meter score, that's our variable, equals, and our test value written here, 63. Okay, so the test value, that goes in your hypothesis. So population average tomato meter score is 63. For your H1, they asked for non-directional. So you say that the population average tomato meter score is not 63. Okay, we don't say greater than, less than, because that's giving a specific direction. We just say it's not 63. Okay, interpret the output. Okay, so this one's pretty straightforward. We are looking for our p-value, which is over here. We have a non-directional H1, so we choose two-sided p, even though they're the same, whatever. And you can see p is lower than alpha, so we would reject our H0 and accept our H1, that the population average tomato meter score is not 63. Make sense?
Yes, and when
Sorry,
report
I
folder.
Oh, I'm sorry.
No, you can go.
Oh, thank you. I thought that if our hypothesis is non-directional, we are using one-sided p and two-sided
No.
for
No,
direct.
no. Remember that example I gave you of, like, you're heading down a road? If it's non-directional, it means whoever gave you directions did not specify left or right. They said it could be left, could be right. No direction, which means you have to contemplate both possibilities. It could be left or it could be right. Okay, so that makes it two-sided. Whereas if the person told you, oh, go down the road and turn right, that's a specific direction, which means you only focus on the one side, the right side, and you can completely ignore the left. So one-sided is directional, two-sided is non-directional. Make sense?
Yeah, thank you.
Okay.
And so about like including the test statistics and the p-value, I just write down the number and that's it. Of course,
Yeah,
but with the p-value, I reject. Or
yes.
No? Yeah.
Yes, that's correct. The question, I know in some of the questions they'll say, please report the test statistic, the p-value. They'll actually specifically ask you to report certain things. They'll say, report the test statistic, report the sample mean, things like that. So in that case, the test statistic is your t-value if you need to report it. And your sample statistics are always up here. So if they want the sample mean, it's right there. And if they want the sample standard deviation, it's right there. Okay, but generally only report the p-value unless they ask. Like even look here, report all the relevant ones, including test statistic and p-value. So they're being specific.
I have one question for like how to write it correctly. So when I want to report my p-value, because in the two-sided p there's a smaller sign, and right now I would report it like p smaller sign and then the p-value. Is that correct, or do I have to do like the equal?
Yeah, that is correct. So the p-value actually has a very strict rule in APA reporting that you always have to report the p-value exactly as it appears, which means it's p is less than 0.001. In the year one course, they don't penalize you for not doing APA reporting properly because that's something that they do in second year. But yes, that is the correct way to report P. And you also, you know how in this course they say, oh, 2 decimal places? That's never true for P. P is always 3 decimal places exactly as it appears.
Okay, the same as test statistic, right? When I report test statistic, I also don't round. Or do I?
No, for the test statistic, 2 decimal places. So you can put that as negative 4.65.
Oh, okay. Okay, thank
Yeah.
you.
When I do a new variable with average, do I need to label it?
You just need to give it a label in the description section. You don't need to give it value labels because if you're creating an average, the variable has to be interval ratio, right? Which means there'll be no value labels here, right? But it's always a good idea to give it a description in the label section.
I have a question. Could you maybe go through the week 4 task 4? Just go through it because I have it, but I'm not quite sure if it's right.
Okay.
Thank you.
Okay, BG sales critics. Okay, so average grade, largest. Let's do it. e.g. sales. The first thing it wants you to do was create the average, right? So you're using a critic score and user score times 10. So remember what I said in the lecture part, that when you create an average, they might even manipulate the variable to make sure it's measured exactly the same way. So you see regular user score is measured from 1 to 10, but they want you to use user score times 10 so that it's also from 10 to 100, same as critic score. Just for fun, these are just things you need to notice. Okay, let's go. So we go transform, compute variable. Waiting for my keyboard. Grade. School. 2. Don't forget brackets. Okay. And we're good. So far, so good? Oh, not. Okay, so there's your new variable. Let's say average grade based on critic score and user score. Okay, and it's an interval ratio variable. It's interval specifically, so we can leave that as none. Lovely. Next thing. Okay. Largest possible value that this newly created variable could take on. Well, the scale was from 10 to 100 originally, and what we did was we added them together and then divided by 2. So largest would be 100 plus 100, 200 divided by 2 is 100. So the lowest and the highest possibilities remain the same, 10 and 100. Okay, what is the mean and standard deviation of this newly created variable? Based on the value of the mean, what is your conclusion? Okay, so it wants you to conclude something only from looking at means, which is going to be a very simple conclusion. But let's look. Analyze descriptive statistics frequencies. Have a look at the average grade. And it wants us to look at the mean and, the standard deviation. Continue and okay. All right, there's your mean and your standard deviation. So the fact that the average score is 77 out of 100, would you agree that that's a pretty high score to have that as the average, right? That's like if the IBCOM GPA was overall IBCOM GPA was like 7.7. That's pretty high. So that's the kind of conclusion you can make from this is that overall these games are just scoring quite high. What you could also interpret is looking at the standard deviation. Oh, the question asks you to only look at the mean, but for interest's sake, the standard deviation is 9.9. So based on the rules of standard deviation, that means that 65% of the data of the scores are between 68 and 86. Okay, so that tells you even more that these games are scoring quite high on average. But that's as complicated as you need to make it. You can't suck more out of your thumb for that one. Okay, and then for this one, prior research on game grade suggests that games released on Sony platforms receive an average grade of 80 from critics and players. Okay, so your variable is the grade from critics and players, which is the variable you just created. And we need to filter the data for Sony. So where is Sony? Gotta look at platform folder. Sony is number 5. Lovely. So we go data, select cases. Okay, great. Okay, and then just to go back to it, just to double check. So the number that they give you in the question, that's going to be your test value, right? That's the number that's also going to appear in your H0. Okay, so to answer question D, which test of significance? The one sample t-test. Why? Because it's only testing one variable. That variable is measured as interval ratio, and it's basically testing if a previously known population mean is still valid. Your H0, in this population, the average grade given to games given to Sony games from critics and players is 80. Okay, your H1, there's no indication that you should make it directional. So you just keep it non-directional and you say that the average grade given to Sony games from critics and players is not 80. Okay, to run, go. Analyze, compare means and proportions of sample t-test, not critic score. Let's reset this. We choose our average grade. And for our test value, we put in 80. And your output should look like this. Our test values are there. And we are dealing with a two-sided P because we did a non-directional H1. And so your p-value is 0.007. That is lower than alpha. So you would reject the H0 and accept the H1, that the average grade is not 80. Good?
Yes, thank you. I have the same.
Perfect. Okay, guys, it's our last couple of minutes. If there's anything you want me to look at last minute, let me know in any of the exercises before we run off. Have you guys had a chance to look at week 6, question 3? That's all.
No, I didn't.
Not yet. Okay, so I'm going to give you a couple of tips on this one. Well, I mean, based on the lecture, this should come, but you need to investigate these two variables that they're involving and check the level of measurement because that's going to tell you a lot. And keywords. So this A, 3A, what's the level of measurement of gender and WOMS 1? You're going to find in the value labels that both of them are categorical. Probably, yeah, both of them are categorical. Okay, which one is independent and which one's dependent? Always ask yourself, which one impacts the other more? Okay, and that one is the independent. And if you look at D, which test statistics should be used if we want to test the significance of the relationship? Okay, so relationship between two categorical variables speaks to a chi-square test for independence. Okay, and that's my last word on the matter. Good luck, guys. Before we go, one last thing. I know this was a lot to take in for, it's 6 hours condensed and it's literally like eight weeks worth of content. So it's a lot of information to take in. And I hope this has been helpful. I hope that the recordings and the slides will be helpful afterwards as well. But yeah, I'd love to know if you can give me an indication of where you are on this scale and if you feel like you have improved, if you feel a bit more ready for your test. Okay, nice. Okay, I like what I'm seeing. Good. So we were getting a lot of 4s and 5s before. So the fact that I'm seeing 7s and 8s, that's really nice. Cool. And guys, just so you know that there is an exam prep training starting on Wednesday if you want to do that. And that's going to be 12 hours of training, but it's going to prepare you completely for your exam. So if you need that help, just sign up.
Is there
Thanks, guys.
any like
Yeah.
other exam training? Because I have class Wednesday and Thursday on these times. So is there any other option for the times or not?
The thing is, there isn't, because I can't make myself available for 3-hour trainings all the time. But if those times are particularly bad for most students, I can speak to the grade guru head to see if he's willing to adjust them. The alternative is private sessions, which you can contact grade guru about, because since I joined, they're going to do one-on-one. And then I do them privately, but it's better if you go through grade guru if you want private sessions. Yeah. I'll speak to him though. We might adjust the days and the times.
Okay, thank you.
Sure. All right, guys, thank you so much for joining. Have a good evening and good luck.
Thank you. Bye.